So, with our first section, we have a logarithm. A logarithm whose sole purpose was to isolate an exponent or thereby give an answer to an exponential equation. So, if the log is already present, we know that if we can isolate it, whatever value is on the other side will be an exponent. So, let's first make our goal to isolate the logarithm by adding 1 and then dividing by 3. So that I have log base 2 of 5x equals 2, right? 5 plus 1 is 6 divided by 3. Go ahead, focus. Let's see if I can get it to fit. There it goes. Therefore, if I take this, the answer to this, meaning the 2, is the exponent for the base 2, which yields a value of 5x. Or, if we write that out, 2 to the second equals 5x. Therefore, x would be 4/5. Okay? Number 2 has a different property we need to be able to operate with. Let's see if I can fix this a little bit better. Oh, that's as good as it's going to get. So, similarly, we're starting with a logarithm. So we'll first condense the logarithm by using the the product property. All right. So they can combine the two logs if we multiply the arguments. So 4x squared minus 1. Again, use FOIL if you're not sure about how I got that. And then from there, we know that the logarithm is isolated, and the answer to the logarithm is the exponent. Let's see if this helps. So, now we'll concentrate on raising the base 2 to the power of 3 and setting that equal to 4x squared minus 1. That's kind of messing with my head. So that then, get on the screen, we have 8 equals 4x squared minus 1. 4x squared equals 9 if you add that 1 over, right? Therefore, x is going to be the square root of 9/4. And we're going to take the positive answer, so that would be 3/2, right? The next order is not a logarithm, but an exponential equation. And likewise, we're going to have to isolate the exponential portion by adding the 7 to both sides, so that we end up with 17. Now 17 is not a power of 4, despite what you like. Therefore, what we've got to do is take the log of both sides. Now you can use ln here, you can use log base 4, you can use log base 10. The key that comes out is that we end up with 2x minus 1 is equal to log 17 divided by log 4. So we'll add our 1, and then we'll divide by 2. And I'm going to write that because I ran out of space. I'm going to write times 1/2. So if you're able to type that in your calculator, log 17 divided by log 4 plus 1, and then take the value of that, that will give you our answer for number 3. Number 4, we're going to do some similar things here, but because the exponential part is not isolated, we're first going to divide by 3. So that we get 25 to the x minus 7 equals 625. All right, focus, there you go. All right, so then we're going to take the log, and I want to do the log base 25 for this one. Like I said, it's not really meaningful here. We can take any log we want, but this one's going to be special because we know this comes down. 25 to a certain power is 625. And you may not know that one in your head, but if you were to type that in, you're going to get 2. And if x minus 7 is equal to 2, then x must have been 9. Alright, remember this log base 25 of 25 is 1. It cancels out. The x minus 7 is left by itself in the front. Okay, number 5. Finally got an e problem. So we'll divide by 3 because that is not part of the exponential portion. E to the x plus 7 now equals 30. So we want to isolate x plus 7 and our base is e. We're going to use ln. Remember, ln finds the power that takes a base of e. So from there we get x plus 7 must be ln of 30. And then the last step would be to, of course, subtract our 7. So that's going to be our final answer for number 5. That is a 7, despite how I wrote it. And then our last one. So I'm going to use a little bit more paper for number 6 because it might take a little more space. So we rewrite number 6. If I can get it on the frame, here we go. 2 ln. You can do it. Oops. Let's adjust just ever so slightly. Yeah, that's great. Okay. So x plus 1 minus ln of x squared minus 1. This one's a bit of a doozy because of the factoring you've got to be able to do. So what we're going to do, we've got to be able to combine the two logarithms. So this one actually becomes the exponent here. So I have ln. Because they're subtracting, I can divide the arguments. So I get x plus 1 squared. I'm going to write it twice because I want to prove a point. X squared minus 1 can be factored as x plus 1 and x minus 1. And what we have happen is one of those cancels. So we're left with ln of x plus 1 over x minus 1 equals 5. Now to get rid of an ln, you take your base of e to both sides, right? And remember, the answer to this is whatever value takes a base of e and gets this. Or you put it on a base of e, it's going to get x plus 1 over x minus 1, and that's now equal to e to the 5th, right? So this is a bit beyond the scope of our algebraic mission in Math 3. This is more along the lines of something you'd see in pre-cal. But nonetheless, we're going to finish it out, multiply by the denominator to get rid of the fraction, right? And then we're going to distribute. So we've got x plus 1 equals x e to the 5th minus e to the 5th. We're going to get all our x's on one side, all our other numbers on the other. So I'll have x subtract x e to the 5th equals negative 1 subtract e to the 5th if you move that 1 over, right? Okay? Clear up a little bit. There we go. And now what we're going to see is that both of those terms have an x, so we can factor it out and rewrite it as x times 1 minus e to the 5th, and that's set equal to negative 1 minus e to the 5th. Therefore, we could divide both sides by that parentheses, and we'll get our final answer. X equals negative 1 minus e to the 5th over 1 minus e to the 5th. There's a couple things you could do with a negative 1. Like I said, this is much further beyond the scope of what we need to be able to do algebraically, but nonetheless, it's a nice strategy to review. Factoring. Alright, so these last two in that section were converting bases. So this next one, we want to convert 4 to the 2/3 to a number represented with a base of e. Now that might seem really weird to you, but if I write this, all I really want to do is say 4 to the 2/3 can be written as e to some power. And your job is to find some power. So again, how are we to find that power? We're going to use the natural log on both sides. Again, that isolates an exponent with a base of e, so that we get x equals ln of 4 to the 2/3. Right? And what we'd actually be able to do there with the 2/3 is move it out front. Say this is really 2/3 ln of 4. That's what x is. Therefore, 4 to the 2/3, focus, yep, equals e to the 2/3 ln of 4. I know that's a really weird idea to you, but it helps if you want to be able to write all numbers with the same base. It has applications from programming to you name it. Okay, so that next one, convert x to the 6 to base 5. It's going to work. We're going to set it up the same way. X to the 6 can be written as 5 to some power. Obviously, I can't use x again. So all we've got to do is solve for y. So what I'm going to do is take the log base 5 of both sides. If it'll focus ever. Yeah, there we go. 5 to the y. So remember, this can move out now that it's a logarithm. Y times a log base 5 of 5 equals a log base 5 of x to the 6th. Right? That's a really big one. So we actually already have our answer there. So we can write it now. X to the 6 can be written as 5 to the, what was my answer? Log base 5 of x to the 6, right? And you can move the 6 out front here and call it that coefficient. We'll talk about half-life a bit more tomorrow. Good luck. Go ahead and keep studying. You can't do too much of that. Not now, at least.